Welcome back in lecture series on topic electrochemistry. In last video, we have studied what is meant by conductivity and molar conductivity and the relation between conductivity and molar conductivity. And you know that molar conductivity is equal to conductivity into volume of solution, or molar conductivity is equal to conductivity divided by concentration of the solution that we have studied. Now today in this lecture we will study the variation of conductivity with concentration. That means what is the effect of concentration on conductivity? How conductivity changes with concentration. So let us see how conductivity, that is K, changes with concentration. Now you know that here water is a poor conductor of electricity because here water dissociates to very little extent and therefore it conducts less electricity because number of ions present in one unit volume of the solution are very less, and ions are responsible for the electrolytic conductance. So water is a poor conductor of electricity, so distilled water does not conduct a current. But in the same water, if you add some HCl, then what happens? The HCl is a strong electrolyte. It dissociates completely and therefore the ions are more in between the two electrodes, that is in a unit volume of the solution. Number of ions, positive and negative ions, increases, and when the electrodes are connected to the battery, then these ions, moment of ions takes place, that is charge transfer takes place from one part of the electrolyte to other part of the electrolyte, and therefore in such a solution conduct a current due to positive and negative moment of positive and negative ions. But if electrolyte is there but it is in a solid state, then positive and there is a strong attraction between positive and negative positive and negative ions, that is electrostatic force of attraction is there, and in such a cases in solid state the current is not passed, no current is passed, so that you know. That means what? Electrolytic conductance involves conduction of electric current. How? By the movement of the positive or negative ions of the electrolyte. That means charge transfer occurs in the form of movement of ions through aqueous solution of electrolyte or molten solution of electrolyte. So electrolytic conductance involves conduction of electric current by movement of ions of the electrolyte, and therefore as there are no movement of ions, no current is flow. Here the number of ions are very less, so it is a poor conductor, and here the number of ions are more and therefore it can conduct electricity. So and charge transfer takes place. So conductivity, electrolytic conductivity, is the electrical conductance of unit volume of solution that we have studied in last two lectures. So suppose these are the two electrode immersed in an electrolyte and these are connected to the positive and negative of the battery, and these are separated by a distance 1 centimeter, and the area of cross section of this electrode is 1 centimeter square. Then the volume of the solution in between these two is how much? 1 centimeter cube, and the conductance, electrolytic conductance, is due to the ions present in this volume of the solution, that is 1 centimeter cube of the solution, and that conductivity is called as what? The electrolytic conductivity of the electrolyte solution. So conductivity depends on the number of current carrying ion present in unit volume of the solution. If the number of ions present in unit volume are less, conductivity is less. And if number of ions in between this region, that is 1 centimeter cube volume of solution, if they are more, then conductivity is more. So see here, conductivity depends on number of current carrying ions present in unit volume of the solution. Remember this sentence, conductivity depends on number of current carrying ions present in unit volume of the solution. So whenever the solution is concentrated, the conductivity is more. So, and whenever the solution is dilute, conductivity is less. So see how. Here, suppose in all these speakers, the volume is unit volume, that is 1 centimeter cube volume is there in all these container. And here, if you take a solution of any ethanol, or if you take a solution of urea or sugar, then no current flow through this solution, because these are non-electrolyte, they do not dissociate, and therefore they do not produce ions, and as they do not produce ions are responsible for the current, that is charge transfer takes place in electrolyte. And here, as there are no ions, charge particles are present, no conductivity. But instead of this, if you take here KCl, if you take KCl solution into this beaker, then what happens? It is a strong electrolyte, so dissociate completely, and number of ions present in unit volume of the solution are more, so they have high conductivity. Such a solutions have high conductivity. But if the solution in this unit volume is of acetic acid, then acetic acid is a weak acid, dissociate to little extent, so number of ions present in unit volume are less, so such a solutions have low conductivity. So here it is a strong electrolyte, so high conductivity due to large number of positive and negative ions present in unit volume. And here the acetic acid solution is there, which is a weak electrolyte, dissociate to little extent, and therefore the number of ions in a unit volume are less, and therefore low conductivity. But see here, conductivity changes with concentration of electrolyte, of both electrolyte, strong electrolyte as well as weak electrolyte. So if concentrated solution of the same substance, concentrated solution of electrolyte, number of ions in unit volume are more, they are close to each other in a concentrated solution, and therefore number of ions present in unit volume are more, and therefore conductivity is more. But in dilute solution, the degree of dissociation increases, number of ions increases, but number of ions in unit volume of electrolyte solution are less. Number of ions in unit volume of the solution are less, and therefore conductivity decreases in dilute solution. So on dilution, what happens? Degree of dissociation increases, total number of ion increases, so conductivity should increase. But conductivity means what? The electrolytic conductance of a solution due to ions present in 1 centimeter cube volume of solution, that is unit volume of solution. On dilution, degree of dissociation increases, total number of ions increases, but the number of ions present in unit volume of the solution are less, and therefore the conductivity decreases with decrease in concentration or increase in dilution. Now see here one example, that is suppose 6 cubic centimeter cube volume of solution is there, and in that 12 ions are there. So number of ions in 1 centimeter cube of solution becomes how much? 12 divided by 6, that is 2 ions are there in unit volume of the solution. And in such a solution, the conductivity, electrolytic conductivity is due to these two ions. Now if we dilute this solution from 6 centimeter cube to 12 centimeter cube, if you double it, then the number of ions increases, but they increases not in proportion of dilution. As here the dilution is doubled, number of ions should be double, but number of ions in 12 centimeter cube are how much? 18 ions are there, and number of ions therefore in 1 centimeter cube is equal to how much? 18 divided by 12, that is equal to 1.5 ions. That means 1.5 ions are present in 1 centimeter cube volume of the solution, and they are responsible for the conductivity. And you know that conductivity depends upon number of ions present in 1 unit volume of the solution. Here number of ions in unit volume of the solution are 2, and here number of ions in unit volume of the solution is 1.5. So conductivity decreases on the dilution, or the on dilution conductivity decreases, or the decrease in concentration. So see here another example. Suppose 100 centimeter cube of solution is there, and it contains 8 into 10 raised to 20 ions. Then 1 centimeter cube of solution contains how many ions? 8 into 10 raised to 20 ions divided by volume of the solution is 100 centimeter cube, that is equal to 8 into 10 raised to 18 ions are present in 1 centimeter cube of solution. That is unit volume of this solution contain 8 into 10 raised to 18 ions. Now suppose here this solution is diluted, the same solution is diluted 10 times, that is volume is increased to 1000 centimeter cube. Then the number of ions increases, that is from 8 to 64, but not in that proportion as the dilution. Dilution is increased to 10 times, but number of ions not increases in that proportion. So here 64 into 10 raised to 20 ions, suppose they are present in the 1000 cubic centimeter of the solution. Then 1 centimeter cube of the solution contain how many ions? 64 into 10 raised to 20 ions divided by volume of the solution is 1000. So divided by 1000, that is equal to 64 into 10 raised to 17 ions, and that is equal to 6.4 into 10 raised to 18 ions. That means in 100 centimeter cube of solution, the number of ions responsible for the electrolytic conduction are 8 into 10 raised to 18. And if it is diluted by 10 times, then the number of ions present in unit volume of the solution are 6.4 into 10 raised to 18 ions. That means number of ions decrease. So conductivity of the solution decreases with dilution. So I hope you understood this concept. Let us see the next, that is variation of the conductivity with molar conductivity in next lecture.